Having talked about the classification, the definition, and the derivation of organic compounds. Now, among the classification, we have the aliphatic organic compound. We want to discuss more on aliphatic organic compound. So, to start with, we are going to talk about definition. We are also going to talk about the classification. We're also going to talk about the examples of aliphatic compounds, and we're going to talk about differences in this section of this video. I'll start with definition. Aliphatic organic compound. We define it earlier. We said they are organic compounds that contain carbon, single bond, double bond, triple bond in a straight chain or branch chain. I'll come again. I said aliphatic compounds are compounds that contain carbon, single bond, carbon, double bond, carbon, triple bond in a straight chain or a branch chain. Now, aliphatic compound can be classified into saturated and unsaturated compounds, meaning that some aliphatic compound we can call them saturated compound, and some we can call them unsaturated compounds. Now, what are saturated compounds and what are unsaturated compounds? Now, come along with me as I define what saturated compound is. Now, saturated compounds, let's pick the first one, saturated compounds. Now, saturated compounds, these are compounds that contain carbon, single bond in its structure. They contain carbon, single bond in its structure. I can also define saturated compound as a compound that contains the maximum number of hydrogen in its structure with a sigma bond. I'll come again. It's a compound that contains the maximum number of hydrogen in its structure with a sigma bond in it. Now, example of saturated compound, we have the alkanes family. Now, alkane family are denoted with their functional group, which is a single bond, carbon, single bond. That's alkane family. And alkane family, we have an example, which is the first member of alkane. We have the methane. And if you check the structure of the methane, we have. Now, if you check them, they have only single bond in it, and all these single bonds are sigma bond. They are sigma bond, meaning they are unbreakable bond. That is why we said saturated compounds are compounds that contain hydrogen bond, maximum number of hydrogen bond, meaning they are what? Unbreakable. Example of another alkane family, we have the ethane, which has 2 carbon atoms. This is also an example of what? A saturated compound under alkanes family. So if you check these alkanes, they have sigma bond all through. Sigma bonds. They're all sigma bonds all through. So this shows that this sigma bond shows they cannot be breakable. That is, it is saturated. From the word saturated, it is what? Saturated. We also have propane, also example of what? A saturated compound which contains 3 carbon atoms in a straight chain, and also contain sigma bonds. So these are examples of what? Saturated compounds. Now, this move to what? The unsaturated compounds. The unsaturated compounds. So what are unsaturated compounds? Now, unsaturated compounds are compounds that contain at least two bonds in its structure. I'll come again. Unsaturated compounds are compounds that contain at least 2 bonds in its structure, meaning they can have from 2, 3 upward. So they are not bond, they don't contain single bond, they contain 2 or triple bonds in its structure. Example of unsaturated compound, we have the alkenes, the alkene family or alkene groups. Then we have the alkyne groups or alkyne family. We also have the aromatic family also, that's the benzenes. Example of alkene group, we have the 18. Now, for you to know that these are unsaturated, we say they are what? They contain multiple bonds or multiple bonds, either 2 or 3, and so on. So alkenes group is denoted as carbon-carbon double bond. All the alkene groups, when you see a carbon-carbon double bond, they are what? Denoted as alkene group, and it falls under unsaturated compounds. We also have the alkyne, which is carbon-carbon triple bond. They also fall under the unsaturated compounds. And the benzene also is a ring that contains double bonds also. It contains double bonds in it, which shows that what? They are also what? Unsaturated. Now, one thing you should know is that in this unsaturated compound, for example, the alkenes, they contain two bonds. We have a sigma bond, which is unbreakable, and we also have a pi bond. A pi bond that is breakable, showing that unsaturated compounds are compounds that can undergo additional reaction in the sense that they are breakable. The pi bonds can be breakable, while the sigma bonds in it are the stronger bond that is unbreakable. Look at alkynes now. Alkynes have triple bonds. One of the bonds is sigma bond. The two of these bonds are pi bonds. Meaning alkynes have one sigma bond and two pi bonds. Alkenes have one sigma bond and one pi bond. So what we are trying to say in essence is that sigma bonds, they are unbreakable. They are unbreakable. Sigma bonds are unbreakable, while pi bonds are breakable. Sigma bonds are unbreakable, while the pi bonds are breakable. Meaning that unsaturated compounds, they contain a sigma bond and a pi bond, while saturated compounds contain only sigma bonds. Now this will take us to the differences between saturated compound and unsaturated compound. Okay, now talking about the differences between saturated compound and unsaturated compounds. Now, one of the things that differentiates saturated compounds and unsaturated compounds is bromine water and potassium permanganate. Now, for saturated compounds cannot decolorize bromine water or potassium permanganate. Cannot decolorize bromine water or potassium permanganate. But unsaturated compounds can decolorize bromine water and potassium permanganate. That is one of the major differences that differentiate saturated compound and unsaturated compound. Another difference that is glaring from what we explained is that saturated compounds, they contain only sigma bond. And we say sigma bond, they are strong bonds that are unbreakable in a compound. That is why they are saturated, because of this particular bond. But unsaturated compounds, they contain both the sigma bond and the pi bonds, meaning that they contain the pi bonds that can be breakable, which is showing that it is unsaturated and it can still be breakable to add more substituents. That is unsaturated compounds. Another difference is it bonds. Saturated compound bonds in air with no sooty flames. So one of the things you can know that this is a saturated compound is when you pick the saturated compound and it's bond in air with no sooty flames, they are what? Saturated compounds. And unsaturated compounds, they bond in air with sooty flames. They bond in air with sooty flames. So bonding in air with sooty flames, especially aromatic compounds, they bond in air with more sooty flames. So that is the differences between the saturated compounds and unsaturated compounds. Now this one will take us to the level of unsaturation. Okay, now I want to talk about the level of unsaturation. Now the level of unsaturation is determined by the multiplicity of bond. One of the things that determines the level of unsaturation is the multiplicity of bonds. And one of it is multiplicity of what? Carbons. Now, what we are trying to say here is that increase in bonds in a compound determines the increase in unsaturation of the compound. So increase in the level of increase in number of bonds in the compound determines the increase in unsaturation of that compound. Another one is, we said, multiplication of carbon, that increase in number of carbon or increase in the carbon content of the compound determines also increase in unsaturation. So what we're trying to say is that increase in number of bonds determines increase in saturation in the compound. Also, increase in number of carbon content, it shows increase in what? Unsaturation. Example is the alkene family. The alkene family is less unsaturated compared to the alkyne family, and alkyne family is less unsaturated compared to what? The aromatic compounds. What we are trying to say is that the alkenes contain the double bond, alkynes contain triple bonds, and aromatic compounds is naturally more saturated compared to the what's called the alkynes family because of the content of the carbons. Now, let's give a data of level of unsaturation. Let's just from this, we have another one is the alkenes. This alkenes is lesser compared to diene. Diene is lesser compared to triene, and triene is lesser compared to polyene. So that is how the trend moves. Then we have another one which is the alkyne is lesser compared to diene. Diene is lesser compared to triene, and followed by polyene, and that's how the trends move. So this is that. We also have the benzene also. How we have the benzene. The benzene, which is lesser compared to the naphthalene, which have two conditions of benzene. We also have the naphthalene is lesser compared to anthracene. Then this one is lesser compared to phenanthrene. So these are the trend of the level of unsaturation of the compound. Okay, I want to answer questions that are related to what we discussed on organic compounds. Now, number one is, which of this group of organic compounds is highly unsaturated? We have options: the alkenes, alkane, alkyne, and cycloalkanes. Now, if we talk about, if we want to answer the question, we need to know what is unsaturated compounds, and we need to know the examples of unsaturated. Now, from this question, the answer is very clear, and it's glaring that the one that is highly unsaturated is the alkynes, because alkynes has carbon-carbon triple bonds. Alkane is not even an unsaturated compound. The alkenes is carbon-carbon double bond, so it is lesser compared to what? Alkyne. Then the cycloalkane is not under what? Unsaturated compound, which is under alicyclic compounds. That's answer the question. Now, number two, which of these cannot decolorize potassium permanganate, KMnO4? Now, from the what we discussed, we talk about the difference between saturated and unsaturated compound. Now, one of the differences is that saturated compounds cannot decolorize potassium permanganate, while unsaturated compounds can decolorize potassium permanganate. So we need to know which one are saturated compounds and which one are unsaturated compounds. Now, from the option we have the benzene, the alkanes, the alkenes, and the alkynes. Now, from this option, benzene is an unsaturated compound, so it can decolorize potassium permanganate. Alkene is an unsaturated compound, can also decolorize potassium permanganate. Alkynes also is an unsaturated compound, which can decolorize potassium permanganate. So the answer we have here is what? Our what? Alkanes, which cannot decolorize potassium permanganate. An example, another one is an example of saturated compounds is or are We have the carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bond, and a benzene, which is the structure of benzene. So we all know saturated compounds are compounds that what contain carbon-carbon single bonds. Very, very clear and glaring. Number 4, we have a group of compounds classified under hydrocarbons. We have amines, we have thiol, we have alkenes, and we have protein. Now we should know that hydrocarbons, what are hydrocarbons? Are compounds that contains hydrogen and carbons. So if we check the options, the amines are compounds that contain carbon and nitrogen, while thiol is carbon and sulfur. So it is not under hydrocarbon, but alkenes, carbon-carbon double bond, which is an example of what is classified under hydrocarbon. Protein actually is under carbon and nitrogen because it's fall under amines compounds. So that is the answer is alkenes, which is carbon-carbon double bond. Now on our memory tip questions, which are questions that are based on what we discussed. Number 1 says, how many sigma bonds can we find in the structure below? Now this is the structure. We want to know the sigma bonds in this structure. Now remember, in a structure, we said any single bond are sigma bonds. But in a pi bond or in a double bond, we have one pi bond and one sigma bond. Now to calculate them, we have 1, 2, 3, 4, 5, 6. Then this is a double bond. Now in this double we have one sigma and one pi. Then 7, 8, 9. So our answer is 9 for this particular question. Number 2, which of the following compound can burn in air with no sooty flames? Now remember when we talk about the differences between saturated and unsaturated compound, we said those that can burn with sooty flames are the unsaturated compound, whereby we have the alkenes, the alkynes, and aromatic compound. Then the one that cannot burn with sooty, we have the alkanes, which are the unsaturated compound. Now if you check this one, this structure is a methane structure. This is the benzene, this is ethene, and this is propyne, which is under alkyne structure. So our answer is A, is the methane, which it cannot burn with sooty flames, which is under saturated compound. Now the next question, I will leave this question to you to find out the answer in the comments. Write the answer in the comments section. Find out the number of sigma bond and pi bond in the below structure. We have this structure. Then you find out the number of pi and sigma bond. The options are there. Then give me the answer in the comments section. Thank you so much.